Can you check if something divides perfectly into a polynomial without doing long division? Yes, you can. Today we learn the factor and remainder theorem. A polynomial is an expression with terms like x squared and x cubed. When we divide it by something like x minus 2, we get a quotient and sometimes a remainder. The remainder theorem says, to find the remainder when you divide f of x by x minus a, just substitute a into f of x. That's it, no long division needed. The factor theorem is even simpler. If the remainder is 0, then x minus a divides perfectly. It's a factor. Think of it like cutting a cake with no crumbs left over. Example 1. Find the remainder when x cubed minus 3x squared plus 2x plus 4 is divided by x minus 2. By the remainder theorem, we just calculate f of 2. Substitute 2 everywhere. 2 cubed is 8, minus 3 times 4 is minus 12, plus 2 times 2 is 4, plus 4. That gives us 8 minus 12 plus 4 equals 4. The remainder is 4. Example 2. Show that x plus 3 is a factor of 2x cubed plus 3x squared minus 11x minus 6. Careful! For x plus 3 we substitute negative 3, not positive 3. f of negative 3 equals 2 times negative 27, plus 3 times 9, minus 11 times negative 3, minus 6. That's negative 54 plus 27 plus 33 minus 6, which equals 0. Since f of negative 3 is 0, x plus 3 is indeed a factor. Common mistake. Many students see x plus 3 and substitute positive 3. Remember, x plus 3 means x minus negative 3, so a equals negative 3. Always flip the sign. Remember this. Sub it in, get the remainder. 0 remainder means it's a factor, and always flip the sign. Write that in your notes for the exam. Subscribe to Ovasaabi for more maths lessons that make exams easy. Visit ovasaabi.com for notes, past papers and more.